Proper arena footing is important. Poor arena footing can cause serious injury as well as affect the performance of your equine athlete. Soundness and quality of performance are the two main motivators for creating a proper arena surface. Every stride of the horse is influenced by how the hoof interacts with the ground and the various qualities of the arena layers. In this video, we will explain how arena footing affects the biomechanics of the horse's stride. Let's take a look at the horse's footfall. 3 phases occur during each stride: the landing phase, the loading phase, and the rollover push-off phase. During the landing phase, the hoof touches the ground and comes to a stop. As the hoof stops, sliding forward and downward into the surface, bones in the leg collide. Concussion can cause shock waves and vibrations to be distributed throughout the ground and leg. During the loading phase, the whole hoof is in contact with the ground, carrying the full weight of the horse and rider. The fetlock, flexor tendons, and suspensory create a shock-absorbing effect. Pressure under the frog stimulates blood circulation through the hoof. The loaded weight increases depending upon movements such as collection, landing from a jump, or galloping. During the rollover push-off phase, the heel rotates off the ground, rolling over the toe for push-off into the next stride. An ideal arena surface allows horses to move efficiently through these phases. The surface should minimize concussion, absorb shock, provide support, and return energy back to the horse. To accomplish this, the surface should have a combination of firmness, cushioning, cupping, rebound, and grip. Here are these characteristics in more detail. The firmness or hardness of the surface affects the amount of support and how the shockwave forces are distributed during the landing phase. While a hard, compact surface offers a high amount of support, it does not aid in absorbing impact shock. Bones and joints in the hoof and leg are forced to absorb this shock, causing horses to modify their stride or jumping form to avoid the sting. Examples of a hard surface include concrete or packed clay. A soft or loose surface, like dry rolling sand, absorbs shock well but lacks support. Overextending the heel or toe damages supporting tendons and ligaments. Muscles and respiration are also fatigued. A surface with ideal firmness offers support with minimal concussions to the bones and joints, and is soft enough to aid in absorbing shock. Cushioning refers to how the arena layers dampen shock during the loading phase. A compacted surface lacks cushion. The arena layers don't aid in relieving stress and shock when the hoof is loaded with the horse's weight. A soft, deep surface has too much cushion. The surface will shift under the foot, causing the horse's body to work harder for support and energy. Soft tissues become overloaded, which can lead to inflammation and other damage. An ideal amount of cushion should distribute shock through the arena layers and provide enough resistance under the hoof for the horse to balance and move into the rollover push-off phase. During the loading phase, the hoof capsule expands. Pressure under the frog and digital cushion aid in supplying blood to the structures in the hoof capsule. As the weight is released, the hoof contracts, pumping blood up the leg and through the body. This process is called hoof mechanism. The surface under the foot influences hoof mechanism. On a hard, compacted surface, the frog has minimal contact, hindering hoof mechanism even further. The amount of weight over the hoof capsule forces blood only through the large veins. The lack of blood flow through the small veins is damaging to the hoof capsule and can lead to problems like navicular disease and laminitis. A soft surface will cup under the foot but may not provide enough resistance and pressure to maximize hoof mechanism. To benefit from hoof mechanism, the surface should cup into the sole and collateral grooves of the frog. Resistance in the surface supports the weight and force placed under the foot, while the pressure under the frog and digital cushion encourage blood flow through the hoof capsule. Closely related to cushioning is responsiveness and rebound. This refers to the resiliency of the surface to return to its original form. returning energy after the weight of the horse is applied. A stiff and compacted surface rebounds energy too quickly, causing additional shock and vibrations to be absorbed by the horse. A deep, dead surface rebounds energy too slowly. The horse must use its own energy in tendons, ligaments, and muscles to push out of the surface. This is also a strain on the respiratory system. An active and springy surface with ideal rebound returns energy to the horse at the same rate it was applied. This reduces the horse's need to use its own additional energy for momentum. Rebound time is dependent on how the surface is used. For example, dressage versus jumping. The tightness of the surface affects grip. Grip aids in absorbing shock during the landing phase and provides support and traction during push-off and on turns. Too much grip stops the foot too quickly. The full use of the horse's stride is restricted, and risk of injury to bones and joints is increased. The extreme tightness also prevents the toe from rotating into the surface for push-off, straining the leg and navicular region. A slippery surface allows for too much hoof slide. The lack of grip causes the hoof to push through the surface, decreasing propulsion. All of this lowers confidence and performance, putting safety at risk. The hoof must be allowed to slide during landing, stopping just enough for the ground to absorb impact forces. The tightness of the surface must provide stability for the horse during push-off and in turns without causing concussion or sliding. The amount of grip depends on how the surface will be used. Poor arena footing increases damage to joints, soft tissue, muscles, hooves, and the respiratory and vascular system. Creating the proper riding surface is necessary to maintain your horse's safety, longevity, and performance. Achieving the ideal characteristics from your arena surface can be done through proper construction, choice of materials, proper watering, and maintenance. Most existing arenas can be cost-effectively rehabilitated to develop an optimal riding surface. At Premier Equestrian, we are the global footing experts. With our extensive knowledge of various arena conditions and construction materials, we can guide you through the process of building a new arena or improving your existing riding surface. This is what Olympian Stefan Peters had to say about us.
Premier's footing is the best we've ever ridden on. It's the perfect combination of materials. It provides superior traction as well as cushioning, retains moisture well, reduces dust, and is very easy to maintain. We couldn't be happier. Premier Equestrian is simply the best.
Premier Equestrian offers free consultation and performs detailed sand analysis reports. We can engineer an ideal riding surface for your lifestyle, riding discipline, and for your horse. Call us at 800-611-6109 or visit premierequestrian.com.